Hi, Poseidon. Thank you so much to you and the Outliers team for having me tonight to represent Interlune. And Jared and Justin, it's a pleasure to see you both again. Uh, Interlune is I'm the CEO and the co-founder of Interlune. We're building the industrial backbone of the space economy. We're based here in Seattle, Washington, with offices in Houston, and excited to share with you today. Starting with my journey in the aerospace industry, I started working on the space shuttle out of college, working on reusable rockets from the very beginning, and with a focus in aerodynamics as an aerospace engineer, worked on parachute systems and worked on close to 20 flights of the space shuttle, keeping our astronauts safe and doing some valuable research and bringing them back to Earth. I left NASA in 1997, moved to Seattle to work for another reusable launch vehicle company called Kistler Aerospace. Stayed there for 6 years. I was a senior program manager. Got involved with a number of major contracts, but ultimately left to join Blue Origin in the very early days. I was employee number 10. Working directly for Jeff Bezos, and I was quickly promoted to president. I was the first president of the company from 2003 to leaving the company in 2018. The company was about 1,500 people when I left. We built New Shepard. We built rocket engines that power both New Glenn and United Launch Alliance's Vulcan rocket, as well as building the team that went on to build New Glenn and recover the New Glenn booster from orbit. And also some of the company founders on my original Blue Origin team are leading companies like Stoke Space, Starfish Space here in Seattle, as well as went on to found companies like Ursa Major, Relativity, and a number of others. I founded Interlune in 2021 with a group of co-founders that are shown right here. And Andrew Hornsby is with us tonight, our COO, an executive at Rocket Lab and Black Sky. Gary Lai, our Chief Technology Officer, worked with me at both Kistler Aerospace and Blue Origin. He was the chief architect at Blue Origin and led the development of New Shepard and got an opportunity to fly to space on New Shepard, which is a unique experience for an aerospace engineer to be able to go fly on a vehicle that they've fly to space on a vehicle that they've developed. James Antipave, our head of product, leads our business development and sales activities. And of course, our co-founder and strategic advisor, Harrison Schmidt, who is the only geologist to walk on the moon, is one of our co-founders and really started this all after leaving the astronaut corps and starting to work at the University of Wisconsin as an adjunct professor, working on applications of helium-3. And we owe a lot to Jack for the business, the idea that we've evolved and built upon. Interlune at a glance, we've raised about $23 million to date, about 18 million in government non-dilutive revenues. And we, unlike many companies at seed stage, we have binding offtake contracts to the tune of $500 million with companies that are producing quantum computing dilution refrigerators. We are focused on helium-3 as a resource, a space resource that we're accessing, and I'll talk about that in a minute. But we're also focusing on building lunar infrastructure, and you've heard from the prior speakers here about this. A difference for us is around construction and excavation and systems that actually operate down in the regolith as opposed to on top of the regolith. And as we've learned from the Apollo program, and we'll continue to learn through our future, the regolith is a harsh environment, and we're developing the expertise to operate reliably in it, and of course, as Jared mentioned, remove dust from our systems so that they can continue to operate well, charge our systems. Our key accomplishments to date: we've conducted 5 lunar gravity flight tests. These are done on parabolic aircraft. We've designed a prototype lunar excavator and built a full-scale unit, demonstrated the pulling of 100 tons of regolith per hour. And we've invented a new technique for cryogenic helium-3 separation. We call it cold capture. We just announced this publicly last Monday. And this is a system that eventually will operate on the moon, but in the near term, starting in 2028, will plug into helium liquefaction infrastructure here on Earth and extract helium-3 so that we can start selling to customers before we even get to the moon. What's next for us over the coming years? We want to launch our first and our second lunar missions. One of those is going on the Flip rover that Jarrett Matthews just talked about. It's a camera, a multispectral camera that we developed in partnership with NASA. We'll fly that and we'll use it to develop analogs and information about where critical resources are on the surface of the moon by measuring titanium content and the age of the regolith. Our second lunar mission is being designed and built right now under a $6.9 million NASA contract that we were awarded in February. This mission is going to weigh about 45 kilograms, or this payload. We call it Prospect Moon. It has a robotic arm, a multispectral imager, a mass spectrometer, and 3 devices to manipulate the regolith through heating and mechanical means. And we're going to use that for a combination of prospecting and also for demonstrating the technologies we need to separate out resources like helium-3 and hydrogen and other resources. That is going to be ready for lander integration in September of 2027. We're also following on cold capture. We're building our first terrestrial plant. We'll plug that into grade A helium plants on Earth, and then we plan to scale that business to generate tens of millions of dollars in recurring revenue. And in the near term, over the next 3 years, we want to demonstrate lunar construction with a tool that we're designing and preparing to send to the moon to plug into an LTV like the one that Astrolab is building to demonstrate site preparation, removing rocks, leveling surfaces. We also plan to demonstrate some elements of cislunar mobility, how to get critical resources and also lunar science samples from the lunar surface back to Earth. And then also industrial scale heat rejection thermal control products that will be required for anything that we or others do on the surface of the moon. The moon-based opportunity is huge, and Jared also already talked about this. But this is a big differentiator for us. And think of it 5 years ago when we started the company, we were kind of going it alone without a moon-based program. We really focused on helium-3, and I think we've been quite successful in pulling in both customer contracts as well as non-dilutive capital in the form of grants from the government. Now with the moon-based program, we're looking at significant opportunities to fly our technologies to the surface of the moon and really de-risk the program in a series of missions. With 73 planned U.S. moon landings over 10 years, we're looking at that as opportunities. And so the challenge for us is to have our payloads ready to go to meet Administrator Isaacsman's call to the industry back in March. You also see SpaceX focusing on the moon now. And that's another business plan that's credible for using lunar resources to build spacecraft structures. We feel that's really great for Interlune. It doubles down on investments in lunar infrastructure, and we see that as a positive. Our customer traction, I talked about $500 million in helium-3 contracts. These are binding contracts with Maybell and Blue Force, 2 of the largest dilution refrigerator manufacturers in the world. Blue Force is actually the largest. We also have a contract with the Department of Energy to sell helium-3. This chart shows the TAMs for the helium-3 business going out to fusion power, which we consider a growth market. But we're really focused on the quantum computing market, which we believe is going to grow to about $1 billion TAM in 2030. We're focused ultimately on the lunar economy, not just helium-3, but rocket propellant, industrial metals, rare earths, and silicon. But at $20 million a kilogram, helium-3 is really the only material valuable enough to go to space and bring it back to Earth to sell. And that's what we intend to start with for our commercial product. Timeline-wise, 2026, developing technologies, conducting our first lunar mission on FLIP, which is scheduled to fly later on in the fall of this year. Uh, in 2028, over the next couple of years, demonstrating the lunar infrastructure technologies like Earth return, thermal control, and industrial construction, with co-funding from a multitude of government agencies. And we plan to build our pilot plant and conduct our second lunar mission, which we call Prospect Moon, and that payload is being built. By the 2030s, we want to be operating helium-3 extraction plants both on Earth and on the moon, and become a multi-service provider in both sides. And then in the 2030s, scale to increase the helium-3 supply by 10 to 100x to support growth in quantum computing, as well as other resources, as I described earlier. Here's a summary of some of the contracts that we've won. And what we're doing is building alongside NASA's Artemis program and investing alongside that program with non-dilutive grants, really helping to co-fund us in a significant way. Starts with our Texas Space Commission grant, which we were awarded last year, just under $5 million, which is co-funding lunar regolith simulants and test capabilities. We had a phase one STTR, which is in partnership with Colorado School of Mines. This is for trenching and excavation technology development for Artemis Moon Base, and it's eligible for phase two and phase three awards, plus matching. We just recently finished up the phase one work, and we are actively, we have in plans and discussions for the next phase. In February, we were awarded a $6.9 million NASA Phase 3 to build the Prospect Moon payload. That'll be ready for integration in September of 2027, and we've been actively talking with the agency about doing a plus-up on that to fund the flight to the moon, which is somewhere between $60 and $80 million. As Jarrett mentioned, we're a team member on the Astrolab CLB-1, and we're really, really proud to be a part of that team. We're supporting with expertise in dust mitigation and space environments, including the delivery of the EDS, the electrodynamic dust shield for the radiator for that rover. This is a human spaceflight program. It really brings us into another level of development, and we're just excited to be a part of it. And then lastly, NASA recently awarded us along the same lines, along the same thread of dust mitigation, a phase one contract for dust tolerant actuator seals, which we're actively developing right now, and this will also be eligible for phase two and three awards plus matching. So we're using these grants as non-dilutive investment to build our technical team, and that's been very successful, building the team up to where it is today, 36 people between Seattle and Houston. Strategic partnerships, Astrolab, obviously we've been working with Jared and his team for a couple of years now in the CLB-1 role as a subcontractor is a next step. But we've also been working with Astrolab and another industrial partner, Vermeer, over the couple of years, looking to integrate excavators into the Flex rover platform. We've had several joint meetings and design studies on that. With Vermeer, we started working with them 3 years ago. They are a privately held U.S. company based in Pella, Iowa, about 4,000 employees. They build agriculture and mining equipment, and we've jointly developed an excavator. This is a picture of our full-scale excavator that was tested in the first quarter of 2025. We are getting ready to expand the partnership beyond excavation and into site prep and construction, and we're going to have exciting news about that soon. We believe the space economy is a $1 trillion economy. The resources on the moon alone can be measured conservatively in the thousands of trillions of dollars when you add up industrial metals, rare earths, water, and helium-3. This is opened up by launch vehicle reusability, which my co-founder Gary and I had a place in pioneering. We think launch vehicle reusability is lowering the price of space flight, but it's only going to get us part of the way there. And the next big lever for lowering the cost of long-term space sustainability is to build things in space using materials that we source from space. And this is what Interlune's all about. This is creating a new market, a whole new industry segment, space resources. And we're starting with space infrastructure and helium-3, and we plan to expand that beyond helium-3 and beyond the moon to Mars, asteroids, and beyond that. And with that, I'm going to close and thank you and look forward to taking any questions.
Thank you, Rob. Again, we will open a question from online and also a question from offline. Is there anyone who have question for Rob? Anyone?
I think we have Titus.
Okay, we can have Titus from online go first.
Hi, Rob. This is Titus from Izumi Space. We are working on lunar brick and tiles makings. I'm wondering that if it's possible, how do you deal with your helium-3 extraction tails of the regulus? Because we think that if your tails is pre-processed in the grain size, we are able to use that as our raw material to make tiles and bricks on the moon. Thank you.
Oh, okay. Yes. So our process for extracting helium-3 is it starts with excavation. We need to process about 100 tons of regolith per hour. The second step in the process is sorting the materials, sorting the rocks from the sand. And we have a design that we've developed and flown in parabolic flight for a gravity agnostic regolith size sorting machine that we've demonstrated about 70% efficiency, and we plan to continue to invest and improve on that. That output of that is the fines and sand that would make our downstream processes more efficient. And they also could be useful to companies doing any kind of ISRU process, including the building of roads and pads and bricks as well. And that is a line of business that we're talking about adding to our portfolio. And it would be a part of our future investment. So hopefully that answers your question.
Great. Do we have any question from offline? Is there anyone who want to ask question for Rob from offline? Oh, yeah. You might need to hold the microphone. Yeah.
So my question is that what's the current cost to bring 1 kilogram of the material from the moon back to Earth? And what's the trajectory that is dropping that in the next 10 years? Because that's going to affect that's how the commercial mining is possible on the moon, or that's doing like rare earth distilling and a lot of stuff like this.
I'm sorry, Poseidon, would you mind repeating the question?
My question is that what's the cost to bring 1 kilogram of material from moon back to Earth? Because that's going to change how we calculate, like how to do other kinds of like mining, commercial minings, and how this is going to change these industries and attracts like other fundings or competitors or investment opportunities.
Yep. We've rolled up with assumptions about launch getting 40 to 50 metric tons of equipment to the lunar surface, plus the development of our equipment, plus the return, the actual harvesting operations, and then the return of the helium-3 gas to Earth. We calculate that at our first entry of 10 kilograms per year, we can deliver that at a gross margin of 50% gross margin. And we expect that with scale, we can improve that over time, especially as we start to sell the other resources, the water and other things that can be extracted from the regolith, we can offset some of those costs and increase our gross margin over time.
Great. If there isn't more question, we gonna group the audience from offline. I might need all the LR's fund team to help us line up seats in the front row, and also maybe move the stand-up banners to this side, and we will have to maybe move you guys to the center. Yeah. 这边都可以坐，这边。Yeah. And for audience from online, we're probably calling it a day for today. If you guys have any questions or investment interest in Volta Space, Astro Labs, Interlune, feel free to reach out to me and David. We are gonna, for audience from offline in Taipei, we're gonna later on take a group photo and also go to lunch. So thank you everyone from online for attending. It's really impressive. Okay.
All right. Thank you, team in Taipei. And thank you to our speakers.